Hello there. Today we are going to talk about SN curves. Here we have a question from the textbook that's asking us to find the fatigue strength in 10 to the power of 6 cycles and 6 times 10 to the power of 4 cycles. The SU is 110 KSI and the SY is 77 KSI. The diameter of this rod is 1 inch. Since the temperature and reliability isn't given, we can assume it's in room temperature with a reliability of 50%. We also assume that there is no actual fatigue data and the ascent curves constructed from the given data is adequate. Let's start with bending loading. The S10 cube is equal to 0.9 SU times CT. In this case, CT is equal to 1 because it's in room temp. This makes it equal to 99 KSI. Sn prime can be calculated using the formula Sn is equal to half of SU. This formula can only be applied when the material is steel. This makes our Sn prime 55 KSI. We then have to use the table to find the values of the coefficients. Since we are looking at bending, CL, CT, and CR would all be 1, with CG being 0.9. In the video, I accidentally circled 1, but used 0.9 for the equations. CS can be found using the graph shown. Since the steel was machined, we would use these values. The CS in this case would be 0.74. Here are all the coefficients we are going to use to find the Sn. The formula we would use is Sn is equal to Sn prime times CL times CG times CS times CT times CR. Using this, we find that the Sn for bending loading is 36.63 KSI. For axial loading, we use slightly different values. Axial loading's S10 cube is equal to 0.75 times SU, which is equal to 82.5 KSI. In this case, the CG is equal to the average of 0.7 and 0.9, which is 0.8, and CG is equal to 1. Other than these two values, the other coefficients are the same. Putting these into the equation gives us 32.6 KSI. Last but not least, there's torsional loading. In this case, CL is equal to 0.58 and CG is equal to 0.9. The Sn value we get from this is 21.2 KSI. The S10 cube of torsional loading is equal to 79.2 KSI. Now that we have all our values, we can start graphing. Starting with bending loading, the S10 cube value is 99 KSI, so we will put it right here. We would then put the Sn value at 10 to the power of 6. We then combine the 2 points, and all the values after 10 to the power of 6 should be the exact same. We then do this for the other types of loadings, and we get this Sn graph. Since we want the fatigue strength values at 6 times 10 to the power of 4 cycles, we draw a vertical line from this point. We then correlate them with the S values. This gives us 58 KSI for bending, 50 KSI for axial, and 38 KSI for torsion loading. And that's how you do an SN graph question. Thanks for watching.